Weird sciencey facts that boggle my mind. If you've ever been sitting in the woods, for me it's usually in a deer stand, one of the things that can be really cool and entertaining to see, and simultaneously insanely annoying, is a woodpecker. And while I'm sitting there freezing to death, I often wonder, how is it that a woodpecker can spend every day of its life relentlessly banging its head against a tree and be perfectly fine? And meanwhile, we have an epidemic of football players failing IQ tests because they've bumped their head a couple times. Now, for some perspective, humans can suffer a concussion at around 40 to 60 G-forces. By comparison, a woodpecker experiences around 1,500 Gs while looking for lunch. If a human was to strap a pickaxe onto their face and play woodpecker, and somehow was able to replicate those kind of G-forces, the very first peck would cause severe brain damage and render you unconscious. Which is a good thing, because the second peck would kill you. So how has the woodpecker not pecked itself into extinction? And the answer is some really cool evolutionary adaptations mixed with, meh. So first, what we know. The woodpecker has an incredibly long tongue for the size of its head. They're kind of like flying anteaters. And this makes sense. They peck little holes and then they use these long tongues to get in there to suck sap out of trees or access insects. But it also serves another function. You see, when a woodpecker isn't doing its best Gene Simmons impression, it needs some place to store all that tongue. And it does that by wrapping it all the way around its skull. This helps hold its skull in place while it's hammering its head against a tree. Their skull also has unique, soft, spongy bone plates that help absorb a lot of that impact. And that's what we know. Scientists for a long time just assumed that these couple adaptations are what made woodpeckers impervious to the same effects on the brain that we have if we bang our head against the wall. And for a long time, nobody bothered to look at a woodpecker's brain to confirm that assumption. See, when humans and other animals suffer brain trauma, the brain responds by building up what's called tau proteins. So these proteins stabilize neurons, and they are essential to a healthy functioning brain. We need them. But the more trauma a brain receives, the more of these proteins it produces to try to stabilize these neurons, and eventually they start interfering with healthy, proper neuron function. These are the same proteins that are associated with Alzheimer's, although it's a little different. Those proteins aren't functioning the way they're supposed to, but as far as I understand it, too much head trauma can also cause those proteins to not function the way they're supposed to. I don't know. I'm not a neuroscientist, but I do know that these are the proteins that they look for to see if a person has brain damage. And at some point, somebody's like, oh, hey, maybe we should actually look at a woodpecker's brain and see if it has brain damage. And what they found is that woodpeckers do, in fact, have way more of these proteins than birds that don't beat their head against the side of your house. But does that mean that their brains are damaged? And this is where we get into the meh part of it. We don't know. Woodpeckers have been around for 25 million years, so obviously it's not inhibiting their ability to survive. So that would lead us to believe if their skulls and their tongues have adapted for this very specific evolutionary function, why would we think their brains had not? And so it would seem that these elevated levels of proteins that would hinder us actually help the woodpecker. We just don't know how or why these large number of proteins don't have the same effect on a woodpecker's neurological function as they do on every other animal with a brain. But the more we learn about why woodpeckers don't get punch drunk, the better we can develop helmets that'll keep people like Aaron Rodgers from becoming people like Aaron Rodgers. And the better we may be able to understand and treat numerous brain injuries and diseases from CTE to Alzheimer's. And the fact that one little bird brain has and will continue to affect the way that humans protect and treat and care for their own brains is pretty mind-boggling.